Stop transcription. Okay, so in this chapter we will study a new approach to clustering, which is called hierarchical clustering. And the idea is, as I said, simple. It is to cluster a sequence of nested partitions, which can be conveniently visualized via a tree or hierarchy of clusters, also called the cluster dendrogram. So here, in fact, we don't fix to ourselves an objective of a number of clusters. We instead try to do somehow all possible ways of clustering with in some sort of a tree, some sort of a step by step, where in the lowest level of the tree, the leaves consists of each point on its own. One way of clustering things is to simply say, okay, I have, say, 100 points in my data set, so I have 100 clusters. وكل point بيكون هو his own cluster. If we do this, we say we are doing a fine-grained clustering. The clustering is fine-grained, يعني حبته صغيرة مثل حبة الملح. On the contrary, in a coarse-grained clustering, we have at the root one single cluster or a few clusters. At the other end of the spectrum, we have very few clusters. So the idea here is to try to find something in between, or in fact to visualize and check everything in between these two extremes. The agglomerative hierarchical clustering methods work in a bottom-up manner, meaning we start with each point of the endpoints in a separate clusters. بنبلش بفرضية إنه كل point هو كلاستر لوحده، ونرجع بنصير repeatedly نعمل merge، نقول لا خليني اجمع هدول الاثنين شكلهم كتير قراب من بعض، قول هيدا كلاستر لوحده. برجع بشوف الاشياء القريبة بعدها كمان بعمل لها كلاستر جديد and so on until at the other extreme we reach the top of the tree where all the clusters are alone. So look at this diagram. This is a dendrogram. In fact, it represents a sequence of nested partitions. At the bottom, we start with this level where all our data points represent each its own cluster. عندي cluster A, cluster B, cluster C, cluster D, cluster E يلي هن data points. This is the extreme fine-grained clustering. طبعا this usually doesn't make sense لأنه هيدا هو نوع من overfitting. يعني this fits very well our data, but it doesn't have any power of prediction later if we try to use these clusters for something meaningful. فإذا الموديل اللي عم نعمله منه meaningful. طيب, in hierarchical agglomerative clustering, what we do is we try to say at the first step, we try to say, let me do a step and group 2 points together. فإذا بقرر بأول step إنه والله خليني A B اجمعهم بكلاستر واحد لأنهم كتير قراب من بعض. بصير عندي A B و C و D و E. Okay, so this is after my first step. Why did I decide to group A and B in the first step مش مثلا D and E أو A and C? Well, there's a reason. حسب هلا there are many approaches. Suppose there's a reason to do this. هلا once I do the first step, I will look again at my data, and for some reason I say I want now to group C and D. So I get this partition A, B, C, D, and E. And this is my partition now for the clustering after these two iterations. Next, I find for some reason from these three clusters A B لوحدها C مع بعض C D مع بعض و E لوحدها إنه هلا the best for some reason for my criterion of grouping is A, B, and C, D, merge them together. فإذا I merge these and E remains alone. So I get this clustering, A, B, C, D, then E, as you see here. A, B, C, D here, and E alone. Now the final step to the root of the three, we group everything together and I get A, B, C, D, E, which is the extreme unique cluster for all the points. هلا in between هون لما يطلع هالدندروجرام ممكن الواحد يعني يستفيد منه ليشوف كل البوسيبيليتيز الموجودين للكلاسترينج وبناء ساعتها على معطيات تانية ممكن يقدر انه which clustering is the most representative, which level, which step of all this, okay, is the most representative of the data. So the dendrogram does not do just one clustering. It gives us almost not all the clusterings possible أكيد لأنه إذا بدنا نقول all بنفوت إنه it's n factorial. No, it's all the possible clusterings that make sense. وبيعطينا إياهم بشكل dendrogram بهالشكل هيدا. هلا agglomerative hierarchical clustering. Okay, let us. It is based first on the distance between the clusters. So let's try immediately with an example. Look at here, this data. We start, say, from a data set of 5 points A, B, C, D, E. And we have calculated the distance, the pairwise distances between the points. Usually this is the first step to do the agglomerative clustering. So you start with a table with the distances between the points. فإذا هيدي التيبل شو أعطتني؟ Distance بين A و B هي 1 regardless of the unit that I am using. Distance A to C is 3, A to D 2 and so on. إذا لاحظوا هيدي التيبل عندي A B C D هون B C D E هون وانتري بتعطيني الديستانس بيناتهم. مصطلقنا من هون هلا. Let's do the first step, and usually the first step is to choose the two elements that have the least distance between them. بلاحظ أنا هون إنه أقرب شيء لبعض A و B لأنه عندهم distance 1. أي شيء تاني هو أبعد. هلا صحيح C و D كمان عندهم distance 1. يعني I could start with this or with this. So randomly I can start with one of them, say A and B. And I group them into one cluster and I move on. Now what I have is clusters A, B, C, D, E, and C, D, and E. So now I get a new table. I need to update my table, the table of distances. But now it's a table of distances between مش بس points and clusters. لأنه A, B هلا صارت كأنها عندي نقطة. طيب بدي احسب هلا قديش ديستانس ل AB مع C، قديش ديستانس ل AB مع D، قديش ديستانس AB مع E. فاذا بدي احط هلا ال A وال B اللي هون يلي طاروا بدي احط محلهم هلا their cluster AB and I need to recompute the distances. Of course البوينتس اللي بعدهم points مثلا C و E كانت distance بيناتهم 3 ضلت 3 يعني ما تغيرت الديستانس بيناتهم. بس هلا بدي احسب انا في عندي concept جديد هي what is the distance between a point and a cluster of points. شو الديستانس؟ هون في عنا يعني عدة approach. At this example we have applied the approach called single link. In the approach single link, when you have a point, a cluster, okay, say this cluster of points and a point, you consider that the distance between the point and the cluster is its distance to the closest point in the cluster. هيدي بعتبرها الديستانس، انه وين اقرب شيء من هالكلاستر لإلي هيدي الديستانس لإلي معها. هيدي الابروش بيسموها شو؟ سنجل لينك. It's not the only possible approach. في عنا approach ممكن تكون complete link اللي هي بحسب الديستانس للنقطة مع أبعد نقطة بتاني ميل. فيني احسب distance او اقول بدي احسب distance مع السنترويد لهالكلاستر، او كمان بدي احسب الديستانس. يعني في عدة approaches رح نشوفهم هلا ونعمل لهم يعني enumeration. For the time being, suppose that I'm using single link agglomerative clustering. So here, what would be the distance of AB to C? It's the distance of C here to the closest between A and B. بهالتيبل عندي C بتقول لي الديستانس تبعتها مع B هي 3 ومع A هي 3، فاذا اوكي نفس الديستانس تطلع هون شو 3. D عندها نفس الديستانس كمان طلعت 2. هلا E اوكي عندها الديستانس ل A 4 والديستانس ل B 3 حسب ما حاشتغل هيك، حسب ما هون بهالاثنين انتريز مبين لي. اوكي فاذا in a single link approach I take the closest، بقول E قريبه ل B3، فاذا هون E the distance to the cluster AB صارت شو؟ 3. انحسبت رجعت هالرو، كل شيء باقي ضل زيته and I move on to the next step. Here I observe that in my table the minimum distance is 1, which is the distance between C and D. So I group C and D and I say now my clustering is A, B, C, D and E. A, B, C, D and E. This is my second level of the dendrogram. And again, at each step, I need to update again my distance table. I have clusters A, B, C, D, and E. Now, what is the distance between A, B, and E? That didn't change. What is the distance between C, D, and E? Okay. The distance of E to C was 3 and to D was 5. فإذا الأقرب بيناتهم لأني عم بشتغل single link بيكون هون الأقرب بيناتهم هو 3 and I take 3. What is the distance between A, B and C, D? إذا هون again I have two clusters and I need to calculate a distance between them. In the single link approach again you take closest to closest، يعني أقرب نقطة بهيدا لأقرب نقطة بهيدا. هيدا إذا كنا مقررين نعتمد approach السنجل لينك. ما عم أقول أنا إنه دايما لازم الواحد يحسب الديستانس هيك. في الحقيقة عدة أمور وابروشز ومعطيات يمكن بتخليه ياخد سنجل لينك أو approach تاني. So here in the example we're applying the single link approach. So the distance between AB and CD would now become, okay, 2, which is the distance between the closest point in CD to the closest point in AB. وطلعت عندي بهالشكل the new table of distances. So here, obviously, 2, 3, and 3, I choose to group A, B, and C, D, and I get my next level, A, B, C, D, and E. And this is the third step in my dendrogram. Finally, I don't have any more choices. I have just two clusters. So آخر step واضح بيكون إنه هو we need to just regroup them and get only one cluster. So that's it. ملاحظين إنه هي بسيطة، هي بس بتعتمد على مبدأ الديستانس. في عنا distances and we try in each step to group the two clusters that have the closest distance, and that's about it. The only complication is or question mark is how to calculate how the distance between the points is calculated in the first place. هيدي ممكن تكون Euclidean distance أو أي norm تانية اخدينا. The other question that complicates things is how do I calculate the distance between clusters if I know to calculate the distance between points. كيف بحسب the distance between clusters? And here again we have, as I said, many possibilities. The between cluster distances are obtained as follows. Well, the distance, of course, the distance between points هي Euclidean distance as given here, the L2. But it could be also any other norm that can be applied. By default الواحد إذا مش محددين النورم بياخد by default الأكليديان distance. هذا شيء طبيعي. If you don't have any reason to consider something else. Now the between cluster distances are obtained as follows. If we consider the approach single link, it is the minimum distance between a point in Ci and a point in Cj. Distance of cluster I to cluster J is the minimum distance between xy, where x belongs to Ci and y belongs to Cj. Another such approach is called complete link. In the complete link approach, it's the maximum distance. يعني نفس الشيء بس بناخذ maximum distance. يعني انه اوكي هيدا كلاستر وهيدا كلاستر. To check if they are candidate for grouping بناخذ اوكي ابعد نقطة لابعد نقطة ونقول هيدي الديستانس بيناتهم. هلا well as you see it's radically different than single link and yields a totally different result. 1/3 possibility is the group average. In the group average, you calculate all the pairwise distances and you average them. Of course, how many pairs of points between cluster 1 and cluster 2 do we have? Of course, it is Ni and J, where Ni is the cardinality of cluster I and Nj is the cardinality of cluster J. You have that many pairs, where for each pair you calculate its distance and you sum over all these possibilities, you average over all these possibilities. فإذا طبعا هذه approach أصعب يعني أطول بكتير. Okay, يعني it's rarely used as is because it's a lot of calculation and if the data set is big, it becomes slow and maybe we can use more systematic approaches such as mean distance, the distance between the centroids of the two clusters. فإذا هون بدل ما نحسب البير وايز وكذا في ابروش ثانيه بتشبهها رح تعطي نتيجه تقريبا مماثله هي انه to calculate the distance between the centroids of the two clusters and this approach is called the mean distance. فإذا في فرق بين انتبهوا المين distance والجروب average distance. Okay, لأنه it's not said that if you take the pairwise distances and you average them راح يطلع عندكم نفس الشيء مثل الديستانس بين اثنين سنترويدز اللي هن للكلاسترز. well بس انه الواحد الجروب افريج هي very slow. I think that what you try to achieve with a group average you can achieve it with the mean distance by considering the distance between the means of the points. بس المشكله هيدي كمان هون انه ما فيكم تطلعوها من الديستانس تيبل. يعني اذا بتطلعوا هون بالديستانس تيبل اوكي عملتوا الاي بي فيكم هون في شيء يعطيكم في عندكم معطيات لتحسبوا السنترويد للاي وبي بهالداتا هاي؟ لا، بدكم ترجعوا للداتا الاساسيه وتجيبوا السنترويد حسب وين A ووين B. اوكي فيهم ديستانس في بيناتهم ديستانس 1 اوكي بس يمكن يكونوا هون وهون يمكن يكونوا هون وهون ما بنعرف السنترويد وين. وبالتالي applying the mean distance needs to have the position of the points while the group average وكل شيء باقي هون single link complete link only needs to have a table of distances not a table of position of the points exactly. فاذا هيدي ما فينا نطبقها الا اذا عندنا البوينتس اساسا هن وين. اوكي مش بس الديستانسز تيبل distance table يلي هي بيناتهم. Finally, one criterion that is popular among data scientists is called the minimum variance or the Ward method of Ward, which is the distance between clusters is defined as the increase in the SSE when the two clusters are merged. يعني we start with two clusters, say cluster 1 and cluster 2. هيدا عنده centroid, هيدا cluster 1 cluster كمان وعنده centroid هون. اوكي هلا كل كلاستر عنده شو قلنا؟ عنده SSE, sum of squared errors, and you remember it is the sum of all these squared distances. Square لها distance, square لها distance, square لها distance, and their sum is called شو؟ is called SSE, the sum of squared errors. هلا اوكي هي اسمها error لانه بمعنى انه if this centroid represents these points فاذا هالديستانس الحقيقيه هي بتكون كانه ايرور اذا بدك تنقل هالنقطه للريبريزنتيف تبعها. That is why we call them errors. But it's really the sum of square distances. So if we have these two clusters, okay, عندهم centroids وعندهم فاذا SSE. هلا if we merge the two clusters into one فاذا if we merge the two clusters into one, we will get some centroid here and a new SSE which is calculated to all the points from the two clusters. The new SSE is certainly, we can prove it, is certainly bigger than the sum of the initial two SSEs. يعني SSEij, okay, I know for sure that it's bigger than SSEi for cluster I and SSE for cluster J. دايما الجروبينج تبعهم بكبر ال SSE. The more clusters we have, the smaller SSE we get. So if we group them, we get a new SSE, and the difference of this new SSE with the old, which is the sum of the two SSEs, هالانكريز هيدا بعتبره هو الديستانس بين اثنين clusters. So the increase of SSE resulting from the grouping of the two clusters is considered as the Ward distance. وهيك طريقة وارد بالدندروجرام انه نعمل الجروبينج دايما بشكل انه دايما نكون عم نعمل مينيموم SSE للكلاسترنج يلي نحن عنا اياه. فاذا بتقول لي بدك تنقل من 5 كلاسترز ل4 كلاسترز، اوكي بتحاول بطريقه وورد انه تعمل لك جروبينج لاثنين كلاسترز مع بعضهم بطريقه انه التوتال SSE يكون minimized. Well, this after some simplifications, okay, the SSE as said here is sigma x minus mu I. This is SSEI, the SSE for cluster I. We know that. Now, after simplification of the formula here, okay, we can get that the distance CI Cj equals Ni Nj over Ni plus Nj, mu I minus mu j squared, where Ni is the number of points in cluster I, Nj is the number of points in cluster J, and here is the square distance between their centroids. And this is a simplification for the calculating the Ward distance between two clusters. So again, well, هيدي لاحظوا يعني بتشبه المين ديستانس، بس الفرق بينه وبين المين ديستانس انه كمان هي عامله مثل ويت لعدد الاليمنتس يلي بالكلاستر. So in fact it's the somehow a weighted version of the mean distance. بوقت المين distance هي كانت هالديستنس هاي اللي هون مثل ما هيدي مثل كأنها عملت لها ويتنج بعدد الاليمنتس بكل كلاستر somehow لتحسبها بشكل weighted أكثر. In any case, these are the criteria for doing the calculating the intercluster distances, and this is how we can do them. Well, this is an example for here or of applying the complete link clustering, for example, على الايريس داتا سيت واعطانا هيدول 3 كلاسترز. well هون في اكسرسايز على يعني ما عم فوت فيهم هيدول. في محاولة هون لحتى نشوف هل الكلاسترنج اعطانا تلقائيا الداتا بتشبه التقسيم على سبيشيز سيتوزا فيرجينيكا فيرتيكولار الكونجنتيجنسي تيبل، ولقينا انه طلع عنا انه لما وصلنا ل3 كلاسترز when we got at some point just 3 clusters, we found that cluster 1 has all the points in setosa and nothing else. We found that the triangular cluster has found all the points in versicolor but just 1 point of Virginica, and the square have got the Virginicas but also 14 points from versicolor. هلا هيدي بيسموها contingency table. later راح نشوف انه هيدا النوع من الاشياء بيسموه confusion matrix، اللي هي بتعطي انه الفرق بين التقسيم اللي نحن عاملينه والتقسيم اللي نحن عم نجرب نلقطه بطريقة ما واللي هو التقسيم الحقيقي. مش ضروري هلا نفوت فيهم هدول، يعني جست عم لكم شو في هون. The only thing is يعني these things that يعني من الشابتر هيدا اللي بيهمني. فهمنا شو يعني agglomerative clustering، فهمنا حسب اي كرايتيريون بنحسب new distance table، وبنرجع بنعمل next step and so on. في كمان هون شيء اسمه لانس ويليامز فورمولا. well it's not much important، بتقول لك هون انه كيف تحسب اذا عندك كلاستر جديد اوكي سي اي جي وكلاستر اي، كيف تحسب الانتري بالنسبه للانتريز الماضيين يلي كانوا عندك. يعني هون اذا انا قلت عملت اي بي جروبينج اوكي، فاذا distance ل AB مع C كيف بحسبها؟ انطلاقا من الديستنس ل A مع C والديستنس ل B مع C وهيك. فاذا the new distance ولانس ويليامز عاطي فورمولا انه the new distance of cluster IJ which is the merging of the two clusters CI and CJ with any other cluster CR is this combination sum alpha I times the distance CI CR sum alpha J distance CJ CR plus beta delta CI CJ plus gamma etc. وهول البارامترز بينجابوا من تيبل هيك محسوبة حسب كل حالة. يعني single link alpha I هي 1/2 alpha J هي 1/2 gamma وماينس 1/2. بالcomplete link عندهم value هالبارامترز. بالجروب average هي NI over NI plus NJ where NI and NJ are the cardinalities of the two clusters that we have just merged together. Okay, وبينحسب كل البارامترز انطلاقا منهم mean distance, wards measure and so on. So هيدي بس just a formula for تسرع الcomputing, but if you are working with an exercise in hand, well it's I don't think anyone will really apply them. So consider just as informative وما مطلوب منكم لا تحفظوها هاي، بس اعرفوا بوجودها هيك كفهم. at the end of the day you need mentally to recompute the new distance table according to the criterion to which criterion we are applying. Okay, بدون ما تطبقوا اللانس formula. And that's it. That's about this chapter. I think it's very simple. And don't ask me. ما بعرف إذا هلأ فعلا طلب عندكم إنه الغي من الامتحان، إنه تكون مطلوب بالامتحان ولا لا.